Okay, so in this example we have actually two ropes, it appears, and we're told that point A moves to the right with the speed of VA, and that point B moves to the left with the speed of VB, and we're asked to determine the speed of block M, which is suspended by one of these two ropes. Alright, so we're used to now at this juncture, I think, solving and using rope length constraints, or rope length constraint problems, respectively. But this is perhaps one of the first examples we've done with actually two ropes. Basically, as you might expect, when you have two ropes, you're simply going to need two constraint equations. And so to start, I'm going to go ahead and add up segments of rope on the left-hand side of this equation, and I'll take this little segment path here. And so if I do that, given in this problem the coordinates xb, xa, xc, and xm, let's see what we can do. So to start, I'm going to note that this top segment here that I'm kind of putting a squiggly line over is of length xb, and then I have two additional segments of rope here, which I'm going to call plus xm, and also plus xm minus xc, respectively, where xm minus xc, of course, accounts for the rope length on the right-hand side of that. And that, of course, has to equal some constant. I can then sum up the rope on the other side, so I have a segment here and a segment that wraps around and comes back. And so if I add that up, I'm going to have a segment of length XA, and then I'm going to add to that two segments of length XC, and that'll equal some other constant, which I'll just call constant 2. Now if I take these two collective equations and take their time derivative, what I'm going to end up with here is from the first equation, VB plus 2VM minus VC is equal to 0. And from the second equation, I'll have that VA plus 2VC is equal to 0. Now at this juncture, you'll note that we're given in the problem statement information about VA, information about VB, but no information about VC. And so I'm going to try to rectify that by solving for VC. So if I call this equation 1 and I call this equation 2, I can start by taking equation 2 and solving that. And if I do so, what I'll get here is that VC is equal to minus VA divided by 2. I can then take that and substitute that into equation 1. And equation 1 is now going to give me that VB plus 2VM minus VC, which is going to be plus VA over 2, is equal to 0. From this equation, I actually want to determine the speed of block M, and so if I solve this for VM, I'm going to get VM is equal to minus VB divided by 2 minus VA divided by 4. And I believe in this problem we're only asked to find speed. Indeed, that is the case, and so this will be the final answer for this problem. I'll go ahead and let you plug in the numbers and work through the rest of it. I feel very confident you can do it. Best of luck.